Hi, I'm coming to you from the North Carolina coast. Weird. I'm down here with my family. So excuse the crazy hair and no makeup, but we're gonna get through this. I want to talk to you about assignment 1 because I'm seeing some of the same problems across individuals, and so instead of sending you emails to each of you, I just thought we'd kind of knock it out altogether. So the very first exercise that you have is the inward shoulder press, and so you have a pretty good picture of that. But I want to make sure that we talk about some of these key terms because people seem to be getting a little bit confused on what the assignment was asking for, or maybe you're not quite understanding some of the planes of motion and some of the kinesiology terms, and that's kind of what my concern is. I'm sorry, I'm sitting here kind of scrolling through the assignment and some of the mistakes that some of you made, so that we can kind of talk about it. So the first one is the inward shoulder press. Like I said, and when we're talking about this, it talks about what is that motion. So for this one, it's the horizontal abduction. Generally speaking, I think everybody was pretty good with kind of what that motion is, what we're looking at. Joint motions, you guys are pretty good at. Plane of motion is where we start to get confused. The way I like to talk about plane of motion is the entire motion has to take place in that plane. It can never cross its axis. So for the first example, when we're talking about horizontal abduction, you're coming across the body. That's a transverse plane, and we know that because it never crosses the axis. If I were to split the body in half, that motion never crosses it. If I look at the other two planes, it is going to eventually touch it. It doesn't in this case. So that's where we get our transverse axis. When we look at our axis of rotation, the way that I like to think of this is if I were to fix that shoulder joint, I'm going to lock it in place, and then that abduction motion is going to kind of swing around it. Where is that locked point going to be? And in this case, it's that vertical or longitudinal axis. Think of it like a pole in the ground. And if I tied something around it, what would that motion kind of look like? Later on, we're going to talk about like the knee. And if I were to kind of draw a line and hook it through the knee, that's the axis that motion is then taking place around. I'm not sure if that helps clear it up a little bit. The other thing to think about is if the motion is taking place completely in the transverse plane, the axis is always going to be the same for every motion that takes place in that plane. So if you've already identified it's the plane, then the axis should come pretty naturally. As far as the muscle that takes place, we're talking about the prime mover that does that particular motion at that joint. So when we're talking about the shoulder with that press, right, we know that it's horizontally abducting. We know that the muscle that we're talking about that's going to help create this motion is going to be one that pulls it across the chest. So that's your pec major, and that means it's concentrically contracting because it's actually getting shorter. Let's take the next exercise. For example, the split squat. So now we're looking at the left knee. Again, if you look at the first picture and the second picture, what's happening is that knee is actually flexing and it's bending. So now you have that 90-degree angle. So you're going from, 10 degrees to a full 90-degree angle. So now we know that our motion is flexion. We're going from almost extended to completely flexed. So in that particular thing, where does that motion take? Sorry, it sounds like there's an ambulance going by. Where does that motion take place? It takes place in the sagittal plane. It never crosses it. Think about it. If I fully extend, right, then I'm going to bump up against the transverse plane. It can't be the transverse plane. And so that's where I kind of come up with that sagittal plane. Okay, again, sagittal plane. We know which axis that's going to be. That's going to be your coronal axis. We can move on from that. Now let's talk about what this muscle contraction is, because I'm seeing a lot of people mess this up. If I am actively flexing, right? My mind is saying, okay, let's do a squat. Let's actively flex. That muscle is actually going to get shorter. If a muscle gets shorter, it's a concentric contraction. And in this case, that's the hamstrings. That's not the quadriceps. Remember, the hamstrings are on the back side. So if I want to flex my knee, I have to contract my hamstrings and make them get shorter. So the next question then asks me, or the next block, about the hip. So let's look at what the hip is doing. The hip is also flexing, right? I'm going from an upright position to a position where my hip is flexed. So even though it's going the opposite direction of the knee, that's still hip flexion. In this case, again, still the sagittal plane, coronal, but now we're looking at either your hip flexors or your quadriceps that are helping to create that motion. And again, they're concentrically contracting because they're getting shorter. We move on to the bicep curl, and this gave a bunch of you guys a little bit of a problem. We're starting with our wrist supinated. We never move our wrist. Our wrist stays exactly in the same position. So what does that mean that our wrist is doing? What contraction stays exactly the same length throughout, never moving? Yeah. So again, we're not actively supinating. It's also not getting longer or shorter. So when I'm completing this task, when I'm doing a bicep curl, it's not getting longer. So it's not an eccentric contraction. We're really looking at this being an isometric contraction. All it's doing is maintaining its stability in that case. Technically, it's the transverse plane, which makes it the longitudinal axis. Again, they're just matched together. And your supinator is the one that's really going to do this. And again, because you're not moving, you're not pronating, you're not doing anything, it's staying the same length. But my elbow, on the other hand, is extending. In this case, my elbow is going longer. I'm trying to take that weight and take it as far away as possible. A bunch of you got kind of confused with the biceps in this case. And that's great. You can say that the bicep is working at the elbow. And if you do choose to say that it's the bicep, it's an eccentric contraction. But is that the prime mover in this particular action? Not really, because we're actively thinking about what we're doing. I'm actively trying to extend my elbow. It's not a passive motion. And if I'm actively trying to do it, then that's the triceps. That's the muscle on the back of the arm. It's trying to actively increase that angle, extend the elbow. So the next exercise that we talk about is the shoulder raise. Great exercise, by the way. So we're looking at the right scapulohumeral joint. So we're really looking at, you'll also hear it, your glenohumeral joint. So again, this is flexion. Again, sagittal plane, flexion, sagittal plane, kind of go together. Your coronial axis, again, sagittal, coronial, go together. What muscle is going to do this? It's the one right in the front, your anterior delt. And again, it's shortening to make the action happen, concentric contraction. When we get down here to the shoulder squeeze, this one's a little bit trickier. So our scapula is retracting, right? So in order to accomplish it, we're trying to squeeze that scapula together. So retraction takes place in the transverse plane. Transverse plane, anterior posterior axis, they go to, I'm sorry, there's so much going on here. Axis go together. Now what muscles are going to do this? You had a couple of choices here. Your middle trapezius does help. The biggest retractors are going to be your rhomboids. And again, they're getting shorter, concentric contraction. So what are your elbows doing? So notice again, just like your wrists